Okay. Okay, so this is a body text directive. Right, and the way these are supposed to work is that, this is code that actually runs at compile time that generates text that then goes in and is compiled separately, right? So this code, you can see earlier demos where I did this. This code is generating a big string that contains the components of this matrix, right? And it's generating it for a matrix of arbitrary dimensions. Okay. Now, let's just find the place that's issuing that error message and see how serious it is. This is broken until we are done. This is broken until polymorph.cpp, line 1494. This is broken until we are done with the polymorphism cleanup. Well, right. So the reason I put that in is because I commented this thing out that says apply modify directives. So we're going to get rid of this. And, well, that's probably in bytecode runner. Apply, modify, no, what? Is that routine not existing? Wait, no, it does. Oh, that's also in polymorph then. All right. Apply, modify directives. So, have the arguments changed? We take an array of directives. Oh, yeah, okay. Interesting. Yeah, we totally changed the parameters here. So this version of apply modify directives doesn't take the arguments as a separate array. Because when I cleaned it up, yeah, okay, so okay. So when we make a struct that's polymorphic like this, let's talk about this for a second. Whoops. When we make a struct that's polymorphic like this, the body of the struct lives in a scope just like it would in C or C++. But these arguments actually live in a parent scope, like between that block and whatever its outer scope would be. And that's called the constants block. And what struct polymorph, part of what that does is fill out the constants block. Now, it probably does that later than this procedure call that we were just looking at. But the way that I refactored apply modify directives, let's uncomment that. That should not remotely compile. Yeah, it doesn't. Doesn't take 6 arguments. So when I refactored that, well, so we used to evaluate the user's value for these constants and pass that in an array here, and then also say like, well, here's the constants block that you should stuff that stuff in. And now that routine just wants the constants block completely filled out in the first place. So there's no argument there, which means I have to do that work of filling out the constants block before I apply the modify. Now I was doing it after, well, because there's this stuff like, I mean, sometimes the choice of what order you do things in has consequences. So, like maybe I just didn't want to construct those data structures because I thought it would be slightly expensive or something. Like here I'm building an array, and if we're not going to use that array, I don't know. Anyway, there's another thing here, which is this fine matching polymorph. Right, so fine matching polymorph has to be called after, so we can't move that. My instinct was to move this up. So fine matching polymorph says, you know, this is a polymorphic struct, and we've already instantiated it once elsewhere in the program for these particular sets of arguments. Don't make a new type, just, you know, return the old type because these types should match, and we canonicalize types that way. So, well, let's just take a look at what happens here. So we apply the modify directives, which I guess now we can verify this, but I guess since we don't pass this in anymore, it modifies the arguments block in place and returns the new things in the arguments block. Then we call fine matching polymorph. And then what are we doing here? For everything in the arguments, if it's a type, we're detecting whether, so after we've done the modify, we want to know whether this is a polymorphic struct or not, just so we can flag it as complete or incomplete, right? So if a struct is still polymorphic after this, like if it's got variables that are not fixed, then it doesn't have a known size in memory or whatever. It's just not a type that you can use in your program yet, but you might be able to further specialize it later. So this is actually a valid thing to do. Anyway. Then we start doing arguments block stuff and copying the struct into a new type and all that. So it looks like what I have to do is pretty simple in theory. I just have to poke the things from this array into this arguments block, which shouldn't be that hard. Does anyone have questions about what the hell I'm talking about before I go try and do this? Anyone? Anyone? Am I generating code as a string and then passing it back to the compiler? Yes, in that particular struct, that's exactly what's happening, yes. Are we ever going to get a video just describing how the compiler works? I did a video like that, and it's up on YouTube. And or about some broad aspects of the compiler. It was something about when I was redoing the dependency system in some way. I was talking about the stages of the compiler, and I made a little graph of it and stuff. I don't have any idea beyond that which video that is, so maybe you can get lucky and someone can point that out. Okay. Well, so when I'm coming in here, I have the array of arguments that are sorted by value. And I eval each one to a literal. And down here I add it to this array I'm going to make a note. Only using this arguments array now for, put this up here, for testing structs, as far as I can tell. Okay, so so I'm going to do some common code down here. Well, I mean, this should be an else here, right? Let's call this. Let's call this result arg. So we get this result arg. In this case, we say. Well, we're just setting it to arg in both cases. Okay, whatever. It might be a little cleaner to differentiate between these things, but we won't for now. And then, so we add it to the arguments. And now we need to stuff it into the types block, the arguments block. So I need to say a declaration equals the struct descriptions arguments block dot members I. That I think has to exist. And it's got to have an identifier. And then I need to find who puts things. I've got some standard things for, I just want to search for constants block. Move matches into constants block. That's not exactly what I want, but bind constants block entry. That's it. Bind constants block entry decal arg. That's all we need to do in theory. Let's go look at this to make sure. We set the expression, we flag it as constant, we set the type. Yeah. So that's for that. Okay. I'm actually going to put this in the to-do list because I don't think we need all this code. I think this really should be like 2 lines if we do it correctly. I'm putting that on the to-do list. I just don't want to sidetrack from what we're doing right now. So we bind that constants block entry. Now, that's in the case of vanilla arguments, but the struct could be varargs, in which case a bunch of arguments get packed into an array. So we need to do it there in the case of varargs. And then, okay, so we apply modified directives. And now we pass in that arguments block, which we filled out. So we got the array of directives, we got the arguments block. We tell it whether it's a silent check or not. We give it the site and the load. Okay, well, maybe that's right. Well, I messed something up. Undeclared identifier, 1461. So I didn't have the struct description. It's not called desk. It's called source desk. Oh, God. Right. It's not as easy as... Okay. This is why I didn't just go ahead and do this back before. So you see, what's going on is we used to call the polymorph and whatever, and then make a resulting struct down here. Well, given the way that we refactored this, so we don't want to modify the constants block on the source struct that's being passed in. We want to modify it on the destination struct that we're creating. And the problem is we're not creating it till down here. So we could create it up here, but then we have to clean it up properly, and we do have this potential problem of doing more work in cases where it matches stuff. But only in the case where something has, we could optimize it later so that we only create the struct early if we have modified directives and need to create the struct early. Yeah. Okay. In principle, we want to wait to create result desk until we know whether this struct is a duplicate to make anything new. However, the simplification of structs, however, do a pretty easy optimization that switches things around so that we don't create a new struct until after we check for, is it called check for duplicates? So after we find matching polymorph in the case where there are no modifying directives, which is probably most cases. Right, okay. So, no, unq takes an expression, so we just pass that. So now we have this error-prone thing. Well, actually, if we report an error, we don't actually have to unqueue it because we're not going to. In a case where we report an error, you know, we're going to stop compiling, so it doesn't matter. We only have to unqueue it down in here. So, well, here, maybe, and here. Okay, so passing result desk in here. Left of members. Oh, is arguments block a pointer? Really? Okay. I guess we set it to null if there's no arguments block. It's probably not worth doing, but whatever. Well, who knows what's going to happen at this point? I changed a bunch of stuff. Well, that's not a surprise. All right, let's see. Oh, I got to change the program that we're running so we can debug it. Oh, those declarations that I swore have to exist don't really exist. Oh. Remember when I just said, oh, arguments block as a pointer, and it might be null? All right, so yeah, I didn't think through the consequences of that, even as I said it. So, so the question is, so I can put guards around these. The question is, what does apply modified directives do in the case of a null block? We will have to remember to test that. Oops. Let's see what that does. All right. Well, we just got our question answered for us. This is weird. Okay, I can also fix this, but why? What's going on? We should have a constants block here. Did I do something wrong? Here's where we copy the arguments block. We have to do all this stuff. I don't know why I didn't pay attention to this. This is becoming a, I'm not sure I love this. Like at this point when things get this hairy, I might instead, note that we're doing all this just because apply modify directives didn't want an array. We could make it take an array probably. I mean, like additionally, let's see. Well, except that run modify directive takes a constants block only. So it wouldn't really help. Yeah, I don't know. I'm not thrilled about this either way, honestly. Arguments undeclared identifier. What? Okay. I made a version of this that stuffs the expressions in anyway. However, it's not right. The way I'm using it here is not right. So what this was doing was saying, oh, let's copy that block, and while you're doing it, stuff the stuff from this arguments array into here. But one of the things I did when I went back and did the refactor that put in the hey to do thing that we originally started working on here. When I did all that, I realized that the order of expressions in this thing does not necessarily match the order here, and so you can't assume that. So now we go look at copy block and see if anyone else is doing that, and if not, we get rid of that parameter. So no, 2 arguments. We're looking for anyone who uses it with 3 arguments. No, 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 no. I mean, he's passing null. No, yes, but that's our current thing. No, no, no. All right, so we're going to get rid of that. Going to get rid of that. I'm going to go back here and get rid of that because we're poking those in ourselves down there. Except no, we're still doing it in the wrong order. Okay, well, in usually the right order, but okay. Fixed order of polymorph variable stuff. Yeah. I'm just going to make that a separate item. Right, so this guy is passing null still. Who knows what that's going to do? Okay, we have something. In the arguments block, and it doesn't have an expression. Now, it is our matrix guy. That's weird. So we're trying to run some code. We're trying to run the modify directive that we just set up for. Wait, what? What? So here it looks like the 0th element has an expression. Well, maybe the 0th element's fine. Let's look at, we gotta look at all three. So the first one has an expression. Second one has no expression, which may actually be fine. It's just we need to handle it differently. Which one are we working on? Demo struct parameters. Right, so there's a default argument here, but if I remember correctly, when we do the analogous thing for procedures, if you don't pass it, then when we get those sorted arguments, it's supposed to have the default argument. So maybe we're not filling it in the same ways for procedures. Oh, I lost the no jobs command line argument. Good, thank you. That is very important if we want reproducible, etc. Good thing we didn't get to the point of trying to do serial numbers. Thanks. Someone says apply modify directives has a lot. That's not a lot of arguments. 5 arguments? Are you kidding me? That's not a lot. What kind of programming do you do? Oh wait, that's run modify directive. You were saying apply modify directives. That's only 5 arguments also. What are you talking about? What are you talking about? All right. Somebody told you if you have more than 3 arguments, you should turn the function into a class. I hope you're trolling. If you're trolling, please leave the channel. If you're not trolling, that's not the kind of programming we do here. All right. There's Uncle Bob. I don't know who this Uncle Bob person is, but I'm not particularly sure I like his advice. Because every time I've heard an Uncle Bob advice, it sure sounds kind of bad to me. But what do I know? OP is one letter away from oops. Yeah, that's true. All right. Someone's trolling me about test-driven development. Guys, if you keep sidetracking me, maybe I won't finish this bug today. This is a pretty big change. So basically what's happening here is we're getting, back when I did the aforementioned polymorphism cleanup, part of the point of that was to bring the handling of struct parameters closer to the handling of procedure parameters, or to make it less weird and stuff, so we could coalesce code. And so there appears to be at least one difference, which is, I want to check to make sure this is a difference. In this apply modify directives, no, not in apply modify directives, before that, when I'm filling out these arguments, oh wait, this is in it. Yeah. Whoa, okay, I was assuming we were in the same place, and we're really not. Like, what? Wait, we're in a procedure polymorph now. We're not in the struct polymorph. We're in the procedure polymorph. We're totally not looking at what I assumed we would be. Did I change this at all? I don't think I did. Okay, this is the constants block we were looking at. What's the name of the first variable A? Wait, and what's the... matrix adds. Let's go look at that. Okay. So like, it may be that we actually fix that problem, and now we're on to a later problem in the same program. I mean, we don't know if we fully fixed it because, like, yeah, so we at least seemed to do this polymorph correctly enough that it doesn't stall or crash the program. Who knows if it's going to do the right thing when we try to instantiate this matrix. But now we're trying to do this body text, which is a different one. And it's a procedure body text and not a struct body text. And you know, the handling of those, they're similar in principle, but the handling goes through slightly different routes. We have two things that are matrices of some kind that we're not specifying. And this is a weird thing. So yeah, this is completely separate from what we were working on. And this constants block has 3 items when it's because this has a C, which is a return value. So it's got an item for A, B, and C. So if we look here at members.data, right, comma 3, which shows us the 3 members of the array, then this one is going to be the identifier for C. So well, maybe that's fine. So we're applying a single modified directive. This is apply modified directives. We only have one directive in this case. It's a body text, but you can actually, it's valid in this language to string a bunch of these together. Not multiple body texts, but you could have a modify that modifies the values to some other values before it goes into the body text. So this basically loops over all the modified directives and all the non-body text modified directives and applies those, right? And then we do the body text at the end. Although, I don't know why I need to go through that much of a rigmarole. I should be able to just apply them in order. Make that a to-do. C is more complex than it needs to be if we require, or if we specify that modifier products run in lexical order, can't we just type through them lexical order here and assert that the body text is the last one? I probably wasn't as clear on the situation. That's probably a relatively old loop. Okay, so we've got multiple things to go off and clean up and simplify later. But for now, we're applying a single modified directive, which of course we're running some lambda. And I guess the lambda has bindings for everything in the block. Yeah, I'm just not handling it correctly. So I actually don't remember. So, you know, we start out and we have a block where A is bound to an unspecialized matrix type and B is bound to an unspecialized matrix type. And C has null as its value pointer because it's not pointing to anything. Now, there was at one point when I had a sentinel value for polymorphic value use, and you had to be bound to that if you were in a constants block. And I actually don't remember if it's supposed to be that way or if I switched it to be null. I definitely thought about going back and forth between those two ways. So I'm not sure if this being null is wrong or if us not handling null is wrong. And that, of course, is confusing. So here's the part where we do it. We say, okay, for every argument in the procedure, we look in that argument expressions array. and then we just run the procedure. And now what exactly is crashing? Let's see who's crashing, because I'm not even sure who would crash, because we're only writing to C. BC debug expression line number. BC debug expression file name. Line 270. Does dynamics specialize? Is barfing. Or the line with the dynamic specialize is barfing. And this instruction, well, it's a respecialize. Okay, that is not surprising at all. This is a hairy operation that we would expect to be broken by substantial polymorph changes. Well, it's not even breaking. We're just asserting that the expression is not null here, which maybe it can be. I don't know, maybe it can be. I mean, maybe this is fine. Or maybe, well, actually, so we have a null literal. Yeah. So let's do that. We may have a constants block entry that is not bound to an initial value. For example, it represents a return type that we want the modify to supply, a modify to supply. This happened in the dynamic respecialize and demo struct matrix add. In case I want to dig that out later when I'm looking at this comment and I'm like, what are you talking about? Who knows if that's right? Maybe. Maybe. Linking sure is taking a long time. Okay, well, something is getting added. This is a can of worms. It's a whole separate problem. Something is getting added to the type table, but it's flagged incomplete. Or it's not flagged incomplete. Okay, yeah, okay. There's a two-phase order in which things get added to the type table if they're a struct, because, you know, we have to wait for all the members of the struct to know certain things about it. So the members have to pass through the pipeline first, but the members need to point at the struct for metadata purposes to tell the user at the struct that they live in, so that struct declaration has to be incomplete for a while. So when we say a struct has been sized, So either this thing passed through here twice, or we failed to flag it as incomplete right now. So let's just see if it passed through here twice. It seems likely that it might have passed through there twice. I don't know. This first time, status flags are incomplete. Second time. All right, so that is the problem. First time, how do we get here? Is this in the respecialize handler? Yes. First time, we have respecialized. And we're hardening this struct, so we're saying, here, buddy. Oh, but I don't know. Let's see where the second time is. Second time is just it's flowing through the pipe. Yeah. So what's going on here is respecialize. So respecialize is a funny bird special thing where, you know, it's a thing you can only do at compile time and it makes a new struct. Because it makes a new struct, but we're using it in a procedure, you could be getting metadata of it down here or all sorts of things. So it has to be completed. Like, we can't wait for it to flow through the pipeline the way normal stuff does. So either we put if statements around that thing so it doesn't get called again when it does naturally flow through the pipeline later. So basically, we're not waiting for this to go through the pipeline. We're just saying, look, we filled it out, we respecialized it, we know its size, so like finalize the struct right here. And that's fine to do, hopefully still. But the problem is that we're doing it again later, when it would normally happen. So I guess I'm going to put a guard around it and just say why that is. So if that was almost a terrible mistake. Operator precedence. Is this not a thing? Tell me what if you're going to underline it in red. I hate this program. It's so useless. All right. Whatever. It's got struct flags. I don't know what your problem is. Oh, because, no, it's not definite, it's ask struct. All right. So if that's incomplete, then we do these things. And I was going to add a comment that says, under normal circumstances, all structs will be complete when we get here. The exception is structs that came from dynamic respecialize, which will have already been sized. So don't do it again. hate this editor. Why am I using it? I don't know. All right. Okay, because I skipped this, the alignment is not set, but I called size struct. What's going on? What's going on? Oh, this is maybe a totally separate problem. Wow. So sometimes when you haven't run a demo in a long time, I mean, maybe this is related, but probably not. So this is complaining about the temporary storage struct, which is in the preload. Now, you know what? That if statement that I put in is either wrong or I think that's wrong. I think for some reason other things are flagged as in or not flagged as incomplete. So I have to see why that's happening. Because this is very early. That's one of the first things that the compiler compiles. God, where was I? Oh, I was editing it in frickin' Visual Studio. That's why. I actually have to put a line of code there so I could put a breakpoint because the compiler's stupid. Okay. Oh, it's not the struct flags, it's the status flags anyway. And it's the type info. Ugh, yeah. I hope somebody caught my stupid thing that I did. I totally assumed it was a struct flag when the code right in front of my face says it's a different flag. Okay. So I can't stand trying to type in Visual Studio anymore. So we're going back to Emacs, line 1169. So size struct doesn't matter if you recall that. I think. Well, so let's make sure when this is set, yeah. And then let's look at size struct. Yeah, we don't want to call that twice. You know what I think we do? I think we do the following thing. Like, rather than writing a big comment, I think we self-document. Struct is already sized by dynamic respecialize. There you go. Now the code is actually says let's reuse that flag. Struct is already sized by dynamic respecialize. Okay. Okay. Now, question is, when we copy something for polymorph, which flags do we copy? I don't know. Don't match case. This is turning into a real deep rabbit hole. Make struct. Okay. We straight up copy the struct flags here. In the copier. Let's keep looking, see if anybody else is an issue. Parsing struct polymorph. Let's look in here about what we do about flags. Nothing. All right, well, that's a little bit concerning. So, all right, but well, usually what I do is the struct comes from enum even exist anymore? No. So usually I say something about struct flags to copy, and when I copy them I say what they are. So struct is foreign, yes, not dynamically specialized, not all members uninitialized, because that happens in the typer, and when we copy we go back to the front of the pipe, so we don't want to prematurely feed that flag. We really only want things that the parser set. And incomplete specialization is the thing, yeah. So down here we say struct flags equals source struct flags, and sorry, that's an equals. Source, I don't know. I guess so. Look at all them warnings. Now let's see what happens. Uh-oh, we still ended up here twice. Why do we end up there twice? So we just set it. It's now 65. Best struct flags better be 65. Yes, it is. So wait, we're oh, this is a different. We ended up here a second time. What? We're respecializing. Okay. The respecialize returned us a struct that already existed. That's my theory. Right? Because remember, in all that polymorph stuff, one of the things we do is we return back a struct that may already exist, and this assumes that it didn't already exist. So, wow, we had lots of problems, but that's what happens when you don't look at a particular piece of functionality for a while. So let me just make sure. So the first time we get that number back, it's an actual new struct, probably. Okay, that's somewhere else. Second time, that means this guy returned it. It found a polymorph match and returned it. Let's make sure that's actually correct, because we could have broken the struct matching. So line 399 of demo struct parameters. Well, okay. We're calling matrix multiply. I don't know. We only ever call matrix multiply 3 times. I'm a little suspicious. I'm a little suspicious. But regardless of whether that has an error or not, it is an error to do what we're doing if it ever hands us back something that already existed. So that we have to fix. So struct polymorph could have given us back a type that already exists. In this case, we do blank to size do all that jazz. If something don't do anything that already existed, else there. Oh, we have all kinds of weird things. What if we somehow get a struct that is in the pipe that is not complete? Is that possible? Does it have something bad to do this? Okay. Well, it may already exist. How do we know that? Unless struct polymorph tells us. Like I could just have struct polymorph give us back another value that says, hey, this thing already existed. But well, what we really care about in this case is whether this struct has been sized operation has happened. Are they pipes? No, it's in builder. So we'll say if well, if it doesn't have a size, we need to size it. And, well, why did I? Define type, not inferred type. That would be the wrong thing. That was almost a very bad error. I'm not sure. I feel like this should probably be true, but I don't know why it's true. The reason why I'm saying I feel like it should probably be true like probably fill struct type definition gets called by size struct or something. Like this code wouldn't have made sense if this type info didn't already exist by the time we got here. But I don't remember why. Oh no, that's not the case at all. Okay, we'll do this. This is a double and. That could have been bad. Okay. That might be some approximation of the right thing to do. Oh, we already had a thing called defen. I don't know, man. Status flags is not a member. What? Where are these? Oh, it's only on type info struct. Oh my God, this is so crazy. If crazy. I don't know, man. I might be tired of digging down rabbit holes at this point. This might be a thing that we continue in a future stream. I did not expect this to be a rat's nest of so many issues. Okay. Oh, right. That assert. Right after I was saying that, I was saying, no, wait, that's not true at all because blah, blah, blah. Wait, why did we end up there twice again? Oh, no, it's okay to end up there twice, right? Okay, where are we now? Now we're in a totally separate issue. Oh my God. Oh my God. So the storage segment of the thing generated by body text is not set. This is whack. This is like a totally different. So now we're just okay. Let's look at what code we're emitting. It's a struct dereference. So we're going to have a expression, line number, expression, file name. Line 2 of added strings. Do added strings go into my current working directory? Where do they go? I should be more specific about it. No, apparently not. Well, I don't exactly know where this file is living. Yeah. We know basically what it is. It's like, it's the output of matrix multiply lambda is going to be, well, matrix add. So it's the output of an add operation for one of these matrix types that we generated, and we're trying to reference the members of the struct. And an assignment, in fact. So we're saying, you know, something.11 equals whatever. And for any declaration on a struct, the storage segment is supposed to be set to the struct. That's how you know where the memory is for that thing. And that didn't happen. And that maybe has something more to do with body text than any of the things that I've been working on. So this might be actually break time. This might be like, wow, man, this demo didn't work for so many different reasons anymore that that lunch is required. I don't know. How you manage memory for the syntax tree. Right now I don't free it at all. Yeah, and each thread has its own memory basin so that you don't have to coordinate at all to allocate, which makes it very fast. Not freeing at all is probably not a viable long-term strategy for very large programs or for long-running compilers. Like you might want the compiler to just be a library in an interactive program that just cranks. So at some point, what we'll do is instead of not freeing at all, we'll have each pool attached to that particular workspace. Remember, each workspace is used to compile a separate program. And then we'll just splash out that heap when we close the workspace. One of the reasons why I don't necessarily feel like it's very productive to free anyway is that most of these data structures that we create are live through most of the compilation process. So like, you wouldn't save that much on memory, I don't think, by freeing. Although, I don't know. I mean, if you're heavily pipelined and the pipeline is succeeding and all that, maybe. No, because things need to refer arbitrarily back to other things. Like as long as you're compiling something new, you have to keep all the old stuff live anyway. So like freeing doesn't even make sense, which is why I didn't bother yet. But it does have to happen long term. Someone says, can't you turn off all the bothersome IntelliSense crap? Probably, and then it automatically turns itself on randomly when I update or whatever. And you just don't, like, dude, I use 5 different computers and 2 different versions of Visual Studio on each of those computers. And keeping all of those in sync, even for any minor setting, is so horrible that I just don't even bother anymore. It's just stupid, right? The only thing that I turn on is auto reload of files, which is a very easy checkbox to find and which doesn't have surprising behavior. All this other stuff is just, I can't even, the amount of effort that it would take to keep these things consistent across all the computers that I use is just enough to make me not bother. And it's their job to ship a good interface. It's not my job to make their shitty interface good, right? So why are they asking me to do a non-trivial amount of work for them? Like I don't even know. So that is my attitude toward all these things, not just for Visual Studio, but for programs like that, generally speaking. A different kind of depression stream. Yeah, it's easy to get upset about the way software is today. It's just really absurd. But I've tried to talk to the Visual Studio people about what they do, and they just have a very different view of reality. It's like a view of reality that is defined by Microsoft corporate politics and not by what actually makes good software, because those are 2 very different things. Yes, I would like to write my own editor to replace Emacs, but I can't write every program in the world simultaneously, bro. You gotta, what do you expect? I gotta finish some things before I do other things. Like, why do people even ask, why haven't you written a new version of this random thing? It's like, I'm already doing 27 things. Like, what do you want? What do you want? Okay, so why, before I go to lunch, I at least want to have a theory to think about why this isn't getting set. This is good though, because the fact that we got to this added strings file, I need to get more robust about knowing where that goes. But the fact that we got to the added strings file means that we actually successfully parsed everything in the main file, I think. Yeah, I'm pretty sure that's what that means. So that's good. So this is definitely progress. It's just, man, there was a lot of problems with this demo. So well, where does it get set? My guess is that this declaration is just earlier in the pipeline than we want it to be, but I don't know. Oh, it gets set in parser? No, that's copy declaration. So really, like this part of solidify and allocate, which does have to do with sizing struct. So if we mess that up somehow, that could in some way be a cause here. So this guy should be queued if all is going well. Yep. And he's in the run pipe. He has exited the build pipe. So in theory, he actually should have had all this stuff set. So we can set a breakpoint in pipe build. I'm going to be a little bit paranoid, so it's 1, 1. So we can set a breakpoint there and build bytecode. We can say well, I wish I'd made that breakpoint right here, but you can't drag breakpoints anymore, even though you could do that in a much earlier version of Visual Studio. I want to drag breakpoints all the time. Any teases about the next big compiler feature? No. It's good, but I don't want to say anything about it yet. I want to get some of this stuff nailed down. Because if you don't fix all these problems, then as you add new big features, they're sort of built on this foundation of sand. It's not good. You need the foundation to be strong. Okay. So let's make sure this is the right declaration. It is. So what's going on? I don't know why I have 2 of these in a row. Probably there was some code in between those that got deleted. It doesn't have an expression. It's not a type leaf. It's not in the constants block. It's not a polymorphic function. It doesn't have a storage segment yet. Wait. How do I get to the struct from here? There we go. So this struct came from dynamic specialize, that's correct. Where's the defined type? Here. The size is 0, which is really not correct. So at that time, when we got this guy back from dynamic respecialize, he was not okay. Let's get the number of this guy just in case. Use that guy. But maybe his size starts out as 0 for some reason instead of -1. Like what? -1. It's getting set to 0. That's crap. Why? It has 0 members in its scope for some reason. When we polymorph this, I goofed something when in the polymorph code, because we're returning a struct supposed to have members and it doesn't. It doesn't. So let's just see what happens here. We make our struct early, like we were saying before. We copy the arguments block, which etc. Maybe we shouldn't do that. I don't know. Okay, so we get our arguments. We're going to skip to here. Thoughts on ECS? I have no idea what ECS is. I've never heard of that. It's just a random acronym as far as I'm concerned. Apply modified directives. Find matching polymorph. Did we match? No. Okay. Okay, so this is the thing that should have put the members in there. But the source description doesn't have data members. I think this is a dependency problem, or No, it's not a dependency problem. So what it is this guy's not correctly waiting. So when you do that thing where you say body text, people have to wait in the pipeline for their body text to fill in. And you know, when I rewrote all this polymorphism stuff, I probably made that work right for lambdas, but for structs I maybe haven't. So the source description, yeah, he's through the pipe, but he has no members, which means he didn't wait on body text. Except I need to think about this. The source for all these polymorphs would correctly not have body, not have members. The first time we polymorph this, the source struct doesn't have members, and that's correct. But we're actually not talking about that. We're talking about the output of the dynamic respecialize, which is this. This is what we're actually looking at. Oh, damn it. Okay, so this is a problem that I don't know how to solve right now. And frankly, I don't know how I solved it before. This is really rough. This is really rough. I don't know. So when we do a dynamic respecialize, it triggers that body text to happen again, which generates a string, right? But back when I was doing that stuff with dynamic respecialize about picking the size and stuff, I said, oh, this is just a real quick operation. We just evaluate the size and all that, right? But you can't do that if you have to like parse a whole file to know what the members are. So I feel like when I did this, I was clear on the constraints of dynamic respecialize in that the size could be wrong in certain cases. And that's just part of the language semantic, that it has to be defined when you know the size and when you don't. And you don't know the size if you use a body text. And maybe I just have to then flag that and generate an error if you do any operation that uses the size explicitly. But here we don't really use the size. Here we do this. So we're only figuring out the type of C here in order to present a return type for this overloaded function for particular sizes of matrices. So we're not doing anything that requires the type to be correct. This is like subtleties of language semantics that always pop up. We're not doing anything that requires the type to be correct. So when I said 20 minutes ago or whatever, ooh, the size is wrong, that's true. And I should make a note of that right now, that we need to think about what that means in the long term. So could be processed yet because we just generated it during the polymorph, and the compiler pipeline may have to chew on that text for an arbitrary amount. So for now, I am just letting it be that the size may be wrong if you try to use the size inside the routine that did the respec, but probably we can flag this and robustly generate an error for the user. Yeah, so dynamic respecialize, what that does is it creates a new type specified by your user code at compile time. And so it's really pushing to the limit what a compiled language ought to be able to do, sort of. I mean, I can imagine more limiter limits, but you know what I'm saying. So it confused me because I forgot this fact, which is why I put it in a very prominent comment. ECS is basically SOA applied to programming. Instead of using AOS to loop over all objects, it's SOA. Why? Oh, you mean entity component system. Yeah, whatever. I'm not very interested in that. The idea of entity component system has nothing to do with how the data is stored. Whether the data is in SOA or whatever is completely orthogonal, right? Yeah, I don't care very much about, like, every game engine probably should have its own slightly different entity system depending on what you want to do. And like, when I look at entity component system kind of designs, I see something that's trying to be too generalized, that doesn't need to be generalized, and that's overcomplicated for what it actually accomplishes. I don't do things like that at all. No, text is actually text. In this case, when I say text, I mean a string of characters that has to be compiled. All right, so I feel like it's time for me to go get lunch, and if we do another stream today, which we probably wouldn't until late tonight, I would pick up where we left off, and so if that type is fine, what was the actual error we were running into? Or if we're okay being wrong about the size, there's actually some deep problems here. Because at that place where I just put that big warning comment, if we earlier I put in a flag to say if something came from dynamic respecialize, don't resize it later. But we actually do want to resize it later because for body text to work, we need to do that. So I actually have to take this flag out. This was not a good solution to that problem. So we're going to do that, and then we're going to do this. So we're still going to do this because there were two things. Remember, one of the things was we have to deal with if we got back a type that already exists. So that we still need to do. But this marking things as sized by dynamic respecialize is not good. We need to recompute the size later. So we really so I'm just putting a little tag there so I can join these comments. So really, I want to prevent this assert from going off. Well, let me put this comment here, so I can think about one thing at a time. If a struct came from dynamic It won't be flagged as incomplete because we already called this routine once, but we use the respec flag to tell us it's okay not to fire the assert. Okay, so yeah. So actually, I'm going to put this flag back. But I'm not going to use it for what I used it for. I'm instead, well, we're going to get rid of this. I'm just going to use it to control this assert, because asserts are important when compilers get complicated, and I don't just want to like delete this one. So I want to say if I could actually move this down to right before that if. Now, I can almost guarantee there's going to be more problems, but it's lunchtime. Let's see what happens. All right. All right. I don't even remember what these breakpoints are for. I'm going to get rid of that one. Well, we do have an assert. We're running an instruction that we're trying to do something of size 0. So we tried to generate code with our incorrectly sized struct. Line 454. Wait, what? What? That's just like we broke something random because this has not, what? Hold on. What are you even talking about? Size is 64. So that's not an uninitialized, that's just a totally different thing. Oh, it's a, so S? Okay, this is a totally different problem, which is possibly good news. Wow, there were so many problems. So what's going on now is this is a static array of 4 strings. So each string is 16 bytes because it has an 8-byte length and an 8-byte data pointer. So that's 64 bytes for 4 strings. And then we're trying to do a vararg spread, which means, you know, take, you know, make one of the empty bracket, what people call slices in some languages. Make a slice that points to this, is what that's trying to do. And the byte code that we generate for that is incorrect. And so what I would have to do is just go to the place that generates those instructions and figure out why I did the wrong thing. And it's probably pretty simple. Like I probably just broke the thing, because one of the things I refactored a while back was like how we designate which type of array is what. So I probably just didn't correctly check those cases here. So it's a totally different thing. All of this is really, the moral of the story is you should keep your test programs in working order, because this was like 5 or 6, maybe 4 or 5 completely separate bugs that had nothing to do with each other. And they were all probably lurking around for a while, and it's just I never tested these specific cases. Like the specific case of turning a static array into a slice as a parameter to a vararg function, like that probably just didn't happen in any of the other test code, right? So this is why, as we work toward release, we're, you know, building up a comprehensive test suite. And one of the reasons why I'm debugging this is so that this can be part of a live automated test process. So it's good progress. It's kind of funny to have to chew through all those one at a time. Actually, you know, I said there was a lesson there, but there's not really a lesson, because had this been a mostly working test program, and then had I caught this before, I would have had to debug this before, and I didn't have to debug it before, and I just had to debug it now. So we're just time shifting when I debug things. And it just seems a little bit funny because this one program has so many problems that are unrelated. But that doesn't mean very much in terms of the amount of work that has to be done to get the compiler working, because you either had to fix those before or fix them now. There's something to be said, like you probably do get a small amount of win if you catch this problem while you're actively doing that refactor because it's warm and you don't get confused about maybe this kind of thing about, you know, me not remembering that there was funniness about dynamic respecialize. But dynamic respecialize is an especially complicated thing. Most things in the compiler aren't that hairy. So I don't know. We'll pick this up on a future stream and figure out why this is doing the wrong thing. Any final questions before we go? Some people are asking about the depression stream. It's not just depression, it's about motivation and things like that. Like talking about depression as an anti-motivation thing. And it's because people ask me about that a lot. Like I got asked about, you know, basically I'm known for doing long projects, right? And a lot of people try to do long projects and get burned out or demotivated or, you know, depressed while they're working on them. And so the goal of this talk is going to be just to discuss techniques for dealing with that. I gave, basically someone asked me this question at HandmadeCon last year, and I gave a very brief answer because we were limited in time. And it was a correct answer, but it was not very actionable because it was too vague and brief. So I've been wanting for like a year now almost, or maybe 8 months, I got the idea to just go in and do a more detailed answer to that question. So that's what this is about. Yeah, there's a new C++ 11 for each and it sucks. Don't even talk about that. Guys, this is a channel where I like to keep the signal to noise high, so if you ask troll questions like injecting anime into Rambus, I'll just time you out. I mean, it's just, I realize, I don't even know why that's a meme or something, but like I realize that you might think it's funny, but when I'm trying to genuinely read questions from people and stuff like that is in there, it's just, I don't appreciate it. And so in the spirit of keeping the signal to noise ratio of this channel high, and not like most Twitch chat, which is just like a scrolling by, you know, garbage waterfall, I will take action about that if you guys keep doing it. So just keep in mind. And that's not a statement for most people, because most people aren't doing that, but there's a couple people who are, and I will not stand for it. I am not going to see anything from CPPCon. I am not interested. The solutions that the C++ people have come up with are so messy and nasty that by the time you get to like generative metaprogramming, I don't even want to know what they've come up with, because they've had many easier problems to solve and basically made a giant mess out of it. So I just have no faith that anything they say is going to be worth following. Will this be a talk that is available online? Yes, it will be. What compilation stages does the compiler currently have? I gave a demo about that previously. Maybe someone can point you to it, or I gave a talk about it. I don't remember the link to it right now, which is why I can't send it to you. Do I think it is worth learning Emacs if you're a computer science student? I don't know. Emacs is kind of old and busted and outdated, and but it's still better for my purposes than most editors, even though it's a piece of junk. So, because most other editors are pieces of junk in different ways, even though they're newer. Most other editors have the disease that modern software has about just being bloated and horrible. So I don't know. Are you satisfied with the current editor that you're using, I would say? How much control will you have over lexical compilation, allowing for house rules for white space brackets? It's a syntax just like C++. So you won't be able to define, at least in version 1 of the language, arbitrary new syntactical tokens unless you make your own preprocessor and insert that into the pipeline, which you can. Have you ever used Ruby? No. Will I talk about some productivity techniques? What I'm talking about is a productivity technique of a certain sort, but it's a psychological management technique. It's not a programming technique. What exact problem am I referring to? C++ is just a giant mess. If you don't understand why I can't, there's like not one thing that I can say about it. Like every aspect of C++ that you look at, you can go into a detailed critique about why it's more complicated than it needs to be. If you want a simple example of that, just look at D, right? Which the mission statement for D was to redo C++ much more simply and effectively. And they did that, right? I mean, they made some language choices that I don't particularly like, which is why I don't use it. But if you want to see a cleaner version of many of the things that C++ did, go look at D. And then you'll understand, like, oh, they really did mess some things up. And then you could ask yourself, how could you improve it even more, and so forth. What do I think about coding conventions, not coding style guide? I don't know what that means. What language isn't a huge mess? There are several that are not a huge mess, but it's all relative. C++ is a way bigger huge mess than most other languages for similar levels of functionality. All right, I'm getting out of here.